Okay, so your multiplication of matrices is what we're going to do today. So it says it is more difficult to describe, and we're going to go over the procedure. Now, the first thing we have to know is that it's only defined when the number of rows in column A the number of columns in A is equal to the number of rows in B. So that's what we're going to discuss in the next slide. So what we usually do is we write the matrices side by side. So let's say the first one is m by n, the second one is m by k. These have to match, and then your result is going to be an m by k. So I'll give you an example with numbers. Let's say the first one is a 3 by 2, and the second one is a 2 by 4. If the number of columns matches the number of rows, then you can multiply it, and the result is going to be a 3 by 4. Okay, so I'm going to give you about 30 seconds to read through slide 15 and slide 16. Is because they were just a lot of terminology. Okay, so in your next slide, in slide 16, it tells you if you have this is your row and this is your column, what you're going to find is the inner product. So what's going to happen is you're going to multiply the first entry in the row by the first entry in the column. So that's why it says A1 times B1, but then you're going to add it to the product of A2 and B2. And then you're going to keep adding them for however many entries that there are. So if this was your matrix here, okay, this is a 1 by 4 matrix. And this is a 4 by 1, which means your result is going to be a 1 by 1. So you would do 2 times 5, which would be 10, negative 1 times negative 4, which would be negative 4, and then the next one would be 0, and then 4 times 1/2, which would be 2. So 10 minus 4 is 6, 6 plus 2 is going to be 8. Your answer matrix for this one, because it is a 1 by 1, would just be 8. Okay, so most of the time they're going to be more than just a 1 by 1, so that's what we're going to practice today. So this is, the next box is just defining the product of AB. And then they're just telling you that the result is going to be the M by K matrix with those entries. Okay, so we're going to call the matrix C, which means if the matrix is called C, when I talk about entries, the entries are going to be C, I, and J, where I is the number of rows and J is the number of columns. The next slide goes over some more definitions. So each entry in the matrix is obtained from a row of A and a column of B. And just like I said, you're going to be multiplying those together. And then that's going to give you your new entry. So the best way to understand this is to actually do it. So that's what we're going to do. So for example 2, we are going to let A be 4, 1, negative 3, 0, 2, negative 1. And we're going to let B be negative 1, 2, 3, 1. And then it says to calculate the products if possible. So the way we determine if it's possible is if the number of columns are going to match up with the number of rows. So if we're doing A times B, okay, Maraf, A is what dimension of a matrix? It's a what by what?
2 by 3.
Nope.
3 by 2.
Yes, so it's always going to be rows first, columns second. So it's a 3 by 2, okay? And then hue B is a what? A 2 by 2. So what you have to make sure is that the number of columns match the number of rows, and if they do, then you can find A times B. So this is going to be a 3 by 2. That's what your result matrix is going to be, is a 3 by 2. Okay, and then if you wanted to right away, you could also see if B times A works. I actually go over this in a different slide, but we can do this right now as well. So B is a 2 by 2, A is a 3 by 2. Do these match? Nope. So this is not possible. Okay, so when you're doing this for your homework, if you could just write that out, 2 by 2, 3 by 2, and then not possible. Okay, so we're going to go ahead and do the one that is possible. So the first thing I do is I write out my matrices. So I have 4, 1, negative 3, 0, 2, negative 1, and then negative 1, 2, 3, 1. Okay, so then the next thing that I do just to kind of help me figure out what I'm multiplying by is I'll underline. So I want to find the first row and the first column. So I'll put little lines there. So if I'm doing the first row, first column, okay, I'm finding C of 1, 1. First row, first column, okay? And then if you guys want, if you want to just watch what I'm doing, and then I'll give you a second to write it down. So you're going to multiply the first term in the row by the first term in the column. So 4 times negative 1, which is negative 4. Actually, for the first time I'll write this down. So it's 4 times negative 1 plus 1 times 3. Okay, so that's going to be negative 4 plus 3, which is going to be negative 1. So when you're putting that in your solution matrix, I'm actually just going to write my solution matrix down here. So my solution matrix, the result is a 3 by 2. So that means it's going to be 3 rows and 2 columns. This is the first row, the first column. So the first row, the first column is going to be negative 1. Okay, now let's do the first row and the second column. So the first row and the second column. Okay, so first row, second column. So I'm going to do 4 times 2 plus 1 times 1. So 4 times 2 plus 1 times 1. And is it okay if I just put 9? So that's the first row, the second column. So I'm going to put that in my matrix, the first row, the second column. Okay, so now we have to move on to the second row. Okay, so now I'm going to do the second row and then the first column. Okay, so the second row, first column. So I'm going to start with negative 3, and what do I have to multiply that by? Good, negative 1. And then Hayden, do you think you can tell me what I'm going to add it to? 0. Yep, and it's really 0 times. Yes. Yep, and then like you just did, if you saw it was 0, I would just write 0. So a negative times a negative is going to be a positive. So that will be positive 3. Okay, do you guys want to try the next one? So the C22. So the second row, the second column. Yeah, give it a try. It's okay. It's okay if you don't do it right the first time. Just see if you can do that. Okay, so your second row, second column, and then is it okay now if I just multiply it? So like negative 3 times 2 is negative 6, and then plus 0, so you'd have negative 6. Is that okay? Okay, and now we're gonna do the final row. So the third row, the first column. Okay, so 2 times negative 1 is negative 2, minus 3, so you should get negative 5.
Wait.
Yep,
So you did 2 times negative 1,
yep,
and then 2 times 3?
and then negative 1 times 3. So you won't distribute, you'll just multiply, so it'll be 2 times negative 1 plus negative 1 times 3. And then why don't you guys see if you can do think you guys got the last one?
Oh, yeah.
What'd you get?
I got 3.
Yeah, 3's right. Okay, because you're gonna do 2 times 2, which is 4, and then negative 1 times 1, which is negative 1, and then you'll get 3. And then that will be your final answer. So this will be your result matrix, and then you just multiply those two together. All right, let's try the next one. Okay, so the rest of this talks about how the product BA is undefined because the dimensions that we already talked about, they're 2 and 3, those don't match up. Okay, so B times A, if you were doing this on your homework, you would see that, and then you would just write undefined. Yeah, we already wrote that down, but I did include a slide for it later on. Okay, so the next thing we're going to talk about are the properties of matrix multiplication. And we talked about properties yesterday with the addition and the scalar multiplication. And I told you the reason why we were talking about those is because they're not always going to hold up for every operation. And that operation is going to be matrix multiplication here. So matrix multiplication is not commutative. It does obey the associative and distributive properties, but it's not commutative. We know that because if we did A times B, then B times A should be the same thing, but it's not. It's undefined. Okay, so the only things that are going to apply are the associative property. So you could multiply B and C together first, and then multiply that by A, or you can multiply A and B and then C, and then the distributive property is also going to work. Okay, so the next example we're going to go over is going to show even though AB and BA are both going to be defined, it doesn't mean that they're going to be equal. So even if you have AB and BA, the result is not going to be the same. So we're going to let A equal 1, 2, negative 1, 4. and we're gonna let B equal 6023.
So they're all 2 by 2s.
Yes, so they're both 2 by 2s. So we're going to calculate the products of AB and BA. So if we do AB, it's a 2 by 2 and a 2 by 2, which means your result is going to be 2 by 2. Okay, and then for BA, it's going to be the same thing. It's a 2 by 2 and a 2 by 2. So because those check, your result is going to be a 2 by 2. But like I said, we're going to see that they're not going to be the exact same. Okay, so first let's do A times B. And like I said, I like to write them out.
Okay, so on the A, it's the rows, and then the other one is the column.
Yes, so I'll always start and I'll do this. Row, column. And then I'm always going to start with the first row and the first column. Yep. Okay, so Taryn, for the first one, can you tell me what I'm going to multiply together? Yep. And then you're going to add that to the product of what? That, yeah, which, yeah. So 2 and 2, yep, which is going to be 4. Yeah. Okay, so 6 plus 4 will be 10. Is that okay? Okay, so, and I'm also going to make my result matrix for A times B. So in the first row, the first column, I have 10.
C1, 2.
Oh yeah, sorry, I said A, and I should have said C. Because that's what we're calling our product. Okay, and then, yep, so then we can do C1, 2. So 1 times 0 is going to be 0. 2 times 3 is going to be 6, so that'll be 6. Okay, Megan, you want to do the next one with me? The second row, the second column? Okay. So I'm going to do what times what?
-1 times 6
Yep,
plus 4 times 2.
yep, good.
Miss Bubba,
Yep.
why is it C2, 2?
The,
Shouldn't it be C21? That's what T1.
oh, when I did 2, 2, sorry. Yeah, thank you. Thank you. We'll do C2, 2 second. Okay, so -6 plus 8 will be 2. Thank you guys for catching that.
Good work, Court.
Okay, and then, yep, so now we're going to do the second row, the second column. Okay, and Courtney, you want to do that one with me?
Yeah, you do. Come on.
4 times 0,
Start with -1.
-1 times 0,
Yep, good.
so that's 0. And 4 times 3,
Yep. Yep, so it'll be 0 plus 12, so then that will be 12. Okay, good. So that's your A times B.
Woo!
Woo. Okay, and then let's do B times A, and actually I'm just going to do it right here on that other side. Not on the other page, just right here. Okay, so B times A, so like I said, I like to write that out. 6, 0, 2, 3, and then A is going to be 1, 2, -1, 4. And if you can do that by yourself, please go ahead and do that.
This is fun stuff, but I gotta say, I did my homework last night,
Uh-huh.
and I did the whole puzzle of the kitchen, and I thought you just like.
Yeah, like straight across. Yeah.
I'm a little angry about that.
so we have to go like fix.
Those two, yeah. I didn't catch it for first hour, but for the other ones, it's just 2 of them.
Okay, will you tell us what the bottom is?
Yeah, yep. So, I'm gonna do first row, first column. So, okay, Ralph, you wanna do that one with me, the first one?
6 plus 0 equals 6.
That, yep, so, yep, 6. Good. Okay, and then Kira, you wanna do C1, 2 with me?
I already have a Can I just tell you what I did?
Well, just tell me how you got there.
Well, I did. Okay, 'cause I just wrote down.
Will you say it again?
I just have the multiplication, so I have like 12 plus 0.
Oh yeah, that's fine. So 6
Okay.
times 2 is 12. Yep. Plus. And you got 0.
times 5.
Yeah, and you got 0 from 0 times 4. Yep. So then you'll have 12. Good. All right. And then Allie, you want to tell me how you did C21?
Yeah, I did 2 times 1.
Good.
And then 3 times negative.
Good. Okay. So 2 minus 3 will be -1. Okay. And then Dan, will you do the last one with me?
4 plus 4.
Good. Okay. So you got 2 times 2 plus 3 times 4, which is 4 plus 12. You will get 16. Okay, so this is proof here that when you are multiplying, it's not commutative. Because if it was, then A times B and B times A would be the exact same matrix. And they are not. Oh, good goodness. Okay, now the last one, it says use page 670 from the text because I wanted you to use those matrices. So, on page 670 is where you have all of those matrices, and I will show you that.
Are you gonna play some jams while we do our SBA lectures? Have you heard
Some
the new
classical for
Noah
study.
Cyrus song? I feel like you would really like it. The step one? Yeah. I love it.
How do you love it?
It's so I really listen.
Okay, so on page 670, they are defining for 21 through 34. They're defining they're defining the A, B, C, D, E, and F, and H. So I'm going to write down our A, H, and C since those are all there. Okay, so your A matrix is 2, -5, 0, 7. Your H matrix is 3, 1, 2, -1. And your C matrix is 2, 0, -5/2, 2, 0, -3.
I think there's like 6 options. Whoa.
Yeah, so because we're only dealing with A, H, and C, we're just going to write those down. And those are all given to you, okay? So those are all be given to you in your problem. We're almost there. So remember that matrices are associative, which means you could multiply this. You could multiply A and H first and then multiply by C, or you could multiply H and C first and then multiply by A. So there's 2 ways to do this. Okay, so you can either do A times H and then multiply by C, or
HC times
yep, but when you do this, you have to do this in the correct order. You can't do HC times A. Okay? And then at a later time I will show you how to do this on your calculator too. But see how A is in front?
Yeah.
Okay, so just remember A times HC does not equal HC times A because that's the commutative property. You have to do it in the right order. Okay?
Parentheses first, so wouldn't it be the same way?
But you still and if you did HC first and then times C, you can't take C and multiply that by AH. Those are not the same. Okay? It's not commutative.
So is there one way that's just easier? I can just remember one way to do it.
Well, I would just do it in order.
Okay. So
Oh,
just
sorry.
do A times
Yeah,
H,
so
do
if
that times C.
yeah. But when you're doing it in your calculator, that can be a little more difficult. So I am going to show you how to do that, but not until next week. Okay, so let's go ahead and I'm going to choose this way, which means I'm going to do A times H first. So if I do A times H, I have 2, negative 5, 0, 7. My H is 3, 2, 1, negative 1. And they're both 2 by 2s, which means my result is going to be a 2 by 2. Okay, and I'm actually just going to make my result matrix right here. Okay, and then I'm just going to put my work underneath. So I'm going to do the first row, first column. So 2 times 3 is 6. Negative 5 times 2 is negative 10. Yeah, and then first row, second column. I'll actually be quiet so you can think about what you're doing. You don't have to just follow me. Is that Skylar that said that?
I was shut up.
Say it, so.
I can't
Let's.
So now we're gonna have to. Oh, I see. I totally get what you mean, Miss Whipple, because it's not the same. It's not one number. Because like what we did over here, when
Yeah.
we did A times B and then B times A,
Right.
they were different.
Right.
So you have to do this one times the C. Oh,
Yes,
okay. I
yes.
got you. Because like when you do A times B and then B times A, they got different answers. So that would be like if you put C on this side times the
But C is
AH,
a
it would be
two-dimensional
different than
AH.
putting C over here.
Yep. So the
So it's gonna
if
be
the
different So always just do this.
number of columns in the rows match up, we're good. Okay, so now we're gonna do. We just did AH. Now we're gonna multiply that by C. So AH, remember that result was a 2 by 2. And then for C, C is a 2 by 3, which means our final matrix is gonna be a what? 2 by 3.
Wait, I got you now. Hold up. Oh, I did.
Okay, so I'm going to take my AH matrix, which is negative 4, 7, 14, negative 7. How did you guys do with that?
Did pretty good.
And then your C is 2, 0. 2, 2, 0.
Oh, goodness. Why is that a negative 5 halves?
And I am just going to make my result matrix here. Okay, so this one's a little bit shorter. So now we're doing first row, first column. So negative 4 times 2 plus 0. Okay, now we're doing the first row, the second column. When you're multiplying the fraction, remember you're multiplying it by the top and then dividing by the bottom. So negative 4 times negative 5 is 20. 20 divided by 2 is 10. And then plus 7 times 2, which is 14. And then this one just has one more column. So we're just going to do C to the 1, 3. So this would be 0 minus 21, which would be negative 21. Okay, so really for your benefit, don't just copy down what I'm doing. You should be doing this yourself. Okay, and then just check to make sure you did it correctly. Yes. We definitely have to have big pictures.
I'm gonna get really angry if my computer doesn't like this shit. It's a really good one.
is your result matrix.
Shoot, I did not get that. Let's start with -4 times 5 tenths is 10. Yeah, I've got 0 here. I'll change it.
Okay, so then your second day of homework, you're just doing 11, 13, 25 through 33 odd. 33 has a part A and a B on it, so you're just going to do part A only for number 33. So for number 33, just do part A.